So let's take a look at this worksheet, and I encourage you to actually have this worksheet printed out with you and to actually pause the video and think about some things as you go along to see if you can answer before I actually give you answers, because that will help you to work out some things in your head. And if you have some things that are right and being confirmed by what I'm saying, then that has more of an impact. And it also has more of an impact if you get something wrong or maybe a little bit wrong, and what I say actually corrects what you wrote. Okay, so we're talking about negative numbers here, and specifically integers, and we'll talk about what that word means in a minute. So what are some examples of places where we use negative numbers in the real world? Pause, think about this, see if you can write down a few examples. Okay, so some of the most common answers that are given are, hang on, are often like temperatures. So we can talk about the temperature outside being 30 degrees below zero, which is cold by either of the common temperature scales. So temperatures, and also money oftentimes comes up. And the negative numbers actually mean debt, usually. So if your bank account is in the red or in the negative, that means you owe more money than you actually have. A couple others that I'd like to point out are, I had one on the tip of my tongue and I need to remember it. Oh, that's what it was. Elevations. And sometimes you actually see negative numbers used, but sometimes you also just say, you see it being said that it's below sea level. And another one that we often use is coordinates. And coordinates are just really a generic term for giving a numerical like number or set of numbers that tells you the location of something. And on Earth, most of us use these coordinates that are degrees, and there's latitude and longitude lines. And so, for example, the city of San Francisco is, the coordinates are 122 degrees west and about 37 degrees north. And so what that means is we have there's two main lines of latitude and longitude. So there's the prime meridian, which tells you that's the sort of origin of the longitudinal lines. And so what we have is so in San Francisco is 122 degrees to the west of the prime meridian. And oftentimes, so you will sometimes see it written as 122 degrees west, or you might see it as negative 122 degrees. And that's longitude. And then the zero line of the, let me just grab another color. The zero line of the latitude is called, can you answer before I actually say it? So that's the equator. And so the 37 degrees north, we oftentimes will say north is going to be our positive and south is going to be our negative. So we could also say this is positive 37 degrees latitude. Okay. So you could think of other places where we use negative numbers if you have any. Now let's look at number types, and we're going to give some definitions here. The natural numbers are also called counting numbers. And they are basically the whole numbers starting with 1. When we first start learning to count, we go 1, 2, 3, 4, 5, and so on. And at some point, we find out that it can be quite useful to have the notion of a 0 or nothing. So the the whole numbers are all of the natural numbers and the number 0. So 0, 1, 2, 3. And then the integers are then going to be essentially the positives and negatives of the whole numbers. So and I should actually put here a ... on the left side to indicate that it, oops. One moment. Okay, so I should actually have a ... on the left-hand side to indicate it goes on forever in that direction as well. So there is a smallest whole number, there is a smallest natural number, but there is not a quote-unquote smallest integer. So a lot of times what I like to think of the integers as the positive and negative whole numbers. Okay. So every number has basically a size and a direction. So one of the things you can think about with the positive and negative numbers is something about, like, I don't know, having assets or debts, something that you have or you have a lack of. But there's also, like, in the case of something like elevation or coordinates or temperature, a negative doesn't necessarily mean that you have a lack of something, right? Negative 2 degrees Fahrenheit doesn't mean you're missing temperature. All it is just a place on the scale of temperature. And so zero in that case is not like a lack of temperature. 0 just means it's just some place on the scale. And so 0 is sort of like the quote unquote center, and it doesn't always have to be thought of as the center, but it is kind of a center value in our number line. And so we could think of the direction as whether we move in the positive direction or in the negative direction. So and then the size would be how far we move away from 0, okay? So if I was to put 0 something like this, then we might say, I'm just gonna label this by 5s. Just to get my bearing here. Okay, so this would be the positive direction. going to the right and the negative direction going to the left. And I want to just kind of point out that the positive direction and negative direction are, in fact, arbitrary. It's kind of arbitrary that we even make this horizontal number line. A lot of times with temperatures, you might think of the number lines as being vertical. But this is just kind of a convention. It is a practice that a lot of people choose. And so, but you can make your number line in any orientation as long as you have it numbered in a way that everybody will understand exactly where like 3 is. So in this case, we have the positive direction going to the right and the negative direction going to the left. And we would say like the number 15 is somehow, the size is 15 here. And the number negative 12, that means I go 12 units to the left of the 0, or in the negative direction from 0. Then I would say the size of that number is 12. Okay, so you might think of like, you know, there's each number has a size and a direction. So, you know, negative 12, the direction is in the negative direction and the size is 12 units. And in this sense, you can talk about comparing sizes of numbers like negative 1,000 is in some ways a bigger number than positive 3. Just because, like, if you're thinking about having assets and debts, if I have a debt of $1,000 and I have $3 in the bank, my debt is larger than my set of assets. And so that's where we might compare the sizes of these numbers, which is different from saying less or greater than. And that when we talk about numbers being less or greater than other numbers, we're strictly talking about how they're ordered on the number line. So the size of a number is also called its absolute value. And sometimes it's also called magnitude. Okay, that is another word that is used mathematically. It's also a word that's used in English. And so we denote the absolute value with this sort of vertical bars. So in the two examples that I lined up in the front, the absolute value or the size of 15 is 15 because this number 15 is 15 units away from 0. And the absolute value or size of negative 12 is 12 because this number, negative 12, is 12 units away from the 0. Okay, it is 12 units big in the negative direction. If you ever use any typewriter-based calculators, such as like spreadsheets or even using like Google as a calculator, then a lot of times they'll use ABS as an abbreviation. And if you want to use these are like called pipe bars, then a lot of times that is, it's above the backslash, which is oftentimes above the return key on a keyboard. So the return key will often have something like a backslash, and then if you hit shift, it'll have that vertical bar. Sometimes it'll actually show this 2 vertical bar thing. I don't know why. I'm sure there's some history to it. Okay, so the direction of the number. So this is where we talk about positive and negatives. Okay, and so we will also call this its sign, S-I-G-N, sign. Okay, so if I talk about the sign of the number 15, if I want to ask what sign is that, you would say it's a positive number. And what sign does the number negative 12 has? You would say it's negative. Okay, so we could say, and this is not really a notation that is commonly used, but so if you have so sign of 15 is positive, and sign of negative 12 is negative. And so don't take too much weight into this, but a lot of times if you have to calculate something, if you want to calculate something with numbers and it matters whether you have a positive number or a negative number, a lot of times people will put +1 and -1 as the sign value. And then the sign of 0 is neither positive nor negative. So it would be 0. So again, so this is not all that important to get hung up on, but we have a tendency to denote the signs with this plus sign or a minus sign. So to say 15, a lot of what that really means is +15. And if there's ever any question about whether you mean a +15 or a -15, it's okay to actually write that plus there just for clarification to make sure that everybody you're talking to understands that you mean a +15. So, so that is the notation for saying which direction the number goes in. And then -12, we pretty much never write negative numbers without writing that negative sign. So that minus sign there really gives you the indication of its sign. So this means that you go in the negative direction from 0. Okay, so two numbers are called opposites if they have the same size, the same absolute value, but they exist on opposite sides of 0. They're like mirror images of each other. So, so let me write that. Two numbers are called opposites if they have same absolute value, but opposite directions. That's a little bit faster. So, for example, 3 and -3 are opposites. So their absolute value, they both have a distance of 3 from 0, but they're in opposite directions. Also, negative 38. If you could pause for a moment, what is the opposite of negative 38? It would be positive 38. So again, I'm not going to put all of the tick marks here, but they are the same distance. It is worth noting here that these are two different scales that I'm looking at between these two number lines. Okay, so this might be a little bit confusing, but after you get used to it, you'll see we denote the opposite of a number with that negative sign. Okay, so that negative sign, we actually have a few different uses for that symbol. It can be the operation minus, as in like 7 minus 3. It can also indicate the sign of a number, as in negative 12, that we use that same symbol to indicate that it's 12 in the negative direction. But we can also use it as an indication of the opposite. So the opposite, if I write the opposite of 3, what is the opposite of 3? Well, it's negative 3. Okay, and writing this down as it's written doesn't actually convey the meaning of what I actually said out loud. The opposite of 3 equals negative 3. So I'm using the same symbol in both cases, but I'm reading it as the opposite of 3 equals negative 3. Okay? And similarly, the opposite of negative 3, what is the opposite of negative 3? The opposite of negative 3 is 3. Okay? These are kind of important to note, and it might seem very confusing, but again, as you kind of do this a little bit more, like if you kind of accept that it does actually make sense to use the same symbol for all 3 of these different places, you'll start to see how it makes sense, and it'll get less confusing as you continue on. So if it feels confusing right now, allow yourself to feel that confusion, but don't get too hung up on feeling confused by it. Okay, the opposite of 23, you should get, it is negative 23. The opposite of negative 7, let's just draw the picture. So here's, if I go 23 to the right of 0, or 23 to the left of 0, those are the same absolute value but different signs. And then there is, let me just put this over further. The opposite of negative 7. So that goes in this direction. So if I go 7 in the other direction, I'm going to get positive 7. Okay, so name 2 numbers that have the same absolute value but different signs. There's many, many numbers you can choose. Same absolute value but different signs. So these should be same absolute values but different signs. These should be opposite numbers. So like 3 and negative 3, or 281, negative 281, and positive 281. Okay, so any two numbers that you choose to write there are, as long as they have the same absolute value, but they go in opposite directions from 0. So those are opposites. Name two numbers that have the same sign but different absolute values. So if I was to write, for example, negative 7, and what's another number that has the same sign as negative 7 but a different absolute value? Well, in this case, there's infinitely many numbers you could choose. So, for example, negative 15. As long as it is in the negative direction, then it can go with negative 7. Or if I was to list 1, then what's another number that has a same sign as 1, but different absolute value? So you can list any positive number. So for example, 11, or 38, or 5,000. Okay, so when we write this notation, this is read as the absolute value of negative 3. Or as the size or magnitude Okay, so take a minute. What is the absolute value of negative 3? It is 3, and why is that? So the magnitude is how big the number is, or you can also think of this as how far that number is away from 0 on the number line. So we can write 3 is because negative 3 is 3 units from 0 on the number line. Okay, so 0, 1, 2, negative 3. So that is 3 units there. And just a little reminder, when we're talking about the number of units on a number line, I'm talking about the spaces, not the tick marks. There are 3 spaces. It's like a distance. Okay. So the absolute value of 17 is 17 because, let's see if you can fill this in. So 17 is 17 units away from 0 on the number line. So if I put 17 there, this is 17 units. Okay, so I'm going to go ahead and make a separate video for the adding and subtracting of integers.